multi-dimensional array also we will see. So here normally the array elements will be, it is used for storing the elements of the same data type. It is used for multiple variable names using the single name. You can sort an element, you can perform matrix operation. For scheduling, you can use if you study OS, you'll be knowing about the scheduling operating system, and you'll be learning about CPU schedulings, all how the job is being allocated. Then normally how in recursive function also. So these are the normal things of your array applications. So normally, so consolidated, I can tell you, when an array is being used, it requires an estimate of the maximum size of the list. That is, see, normally you have declared array of 100. You have given array of 100. Okay. And now you are using only in that 10 spaces only. So but once you declare array of 100 itself, what will happen is the memory space will be allocated for the particular array which you have been declared. So there will be large amount of memory space wasted. So in other word, I can tell you, if you are going to insert a particular element or in an array, I'm telling, if you are going to insert at position 0 or making a new element, first what you have to do, you have to first push the entire array. Maybe if you are inserting in the next location, it does not matter. Maybe you are already there are 5 elements, you are going to insert the particular element in the 6th position. There is no need of any change where you are going to push or the before elements. Okay, just you are going to insert in the 6th, then it will then you are giving another element which gets inserted in the 7th position. Likewise, your elements gets inserted. But in case I am giving a position, like already there are 5 elements in the array, but I am giving a position like I want to insert it in the third location. In that case, what happens is the element which are already in the 3rd position and the elements which are after the 3rd position has to be shifted the other side or down. I can tell you, has to be shifted. You have to push the entire array down. Then only you can insert the element, the required element in the position which you want to do. So here what happens, you have to first push the entire array down to make a room for space for it. So there the time complexity, time consumption is there. Similarly, when you are deleting an element also in a particular position, you have to shift. Maybe you are deleting the 2nd element, so the 3rd element has to be shifted to the 2nd element. So what happens again, the request, shifting of elements has to be done from the 4th position to 3rd to 2nd. Likewise, there will be shifting. So while inserting, there is pushing down of the array, and while deleting, there is shifting of the elements to be moved up. So in general, you can tell that half of the list has to be moved either up or down in any of the operations. So this is the disadvantage which we are facing it in the array. So we are going for linked list. Linked list, what will happen is dynamically only you will create the array itself. So when you create the particular memory dynamically, or the whatever space which you are creating dynamically allocation, what it will help is, if you are removing, you can, if an element is inserted, at that time only the particular space itself will be getting allotted. If you are removing or deleting an element, you can free the particular space also. Free will be there too. So there is a dynamic memory allocation. There is a procedure to allocate dynamically, as well as when you are removing the element in the list, in a linked list, there is a procedure for freeing the space also. So what we are avoiding is the disadvantage in array is being overcome in your linked list by saving the memory space, by creating dynamic memory allocation. So this is what happens in linked list. Then in your stack, queue, tree, graph, everywhere we will be using only dynamic memory allocation. Okay, so coming to this, the normal array declaration will be integer array of 10, or you'll be giving you are giving the, in the variable itself you are giving the size, and that you are now giving it, passing it into the array. So anyway, this 10 is only will be taken by this. Then like this also you can give if you want to increment the array. So this is what normal array declaration. In 2D array you will be giving based on rows and columns. So this happens. This is normal array declaration. But when you go for dynamic array declaration, forget about this bullets, I'll remove it. So here what happens is you're creating an array here, array size array, okay, integer, and that you are now scanning of using the you are using scanf to get the array size. Now I'll change it after this. I'll change I'll repeat it with the same names throughout. Your names has been changed. So now what happens is, for the particular array one, you are creating the memory allocation, dynamic memory allocation. Array declaration is done here. So I think hopefully you would have learned the dynamic memory allocation. What is that syntax in the PPS itself? You will be having the syntax as like this only. You have to give the type def, then again the malloc, then the size of the particular type. Okay, so particular array size. So now array 1 is only created dynamically for inserting or deleting any elements. So now this P11 is same as this array 1 only. I will change it later. Array 1 is the same thing. Now the particular size is being whatever size which dynamically gets allocated when you are going to insert one element, only a size of 1 only will be created. Then again the second element when you want to create, again a dynamic allocation will be created over here. Similarly third, fourth, etc. So what happens is, based on how many number of elements, see initially itself it will be asking for you, if you want to create a linked list, initially the input the user has to give, maybe my list should contain 5 elements. My similar like an array, you are assuming that your linked list should contain only 5 elements. So that means your size is 5 over here. Okay, so dynamically 5 array size, 5 memory space will be created dynamically, and using the for loop now you are going to get the elements one by one. So how you are using is, either there are two types in getting the array dynamic memory allocation inputs. That is how you are getting is, see here ampersand P11, that is same as your array 1. Array 1 is the same name, or you can give your P11 or this array 1. So what happens is, based upon the size, maybe your size is 5, so I is equal to 0, 1, 0 less than 5. So it will get the first element. The first element can be scanned, or the input can be through ampersand the particular array name of 5. I think yesterday someone asked about this. Question was queried by someone. How come for an array element, how to get the input when by using pointers? So see here P11, that is your array name of the, you have to give the, in square bracket you can give the size. So each time when initially what is the array's I value 0. So it will get the first element from us. Then it will increment the I, and again it will check and it will get the second element. Similarly, it will get until how many allocation you have been given here, it will get it. Else you can use this procedure, or else you can use this also. You can follow this, or else you have to give like this P11, that is your array name plus I. Plus I means it can take, first time it will take 0, second time it will take 1, third time it will take 3. Likewise it goes until your size of what you have declared, what you have given us during the runtime. So this is what your array dynamic array declaration or memory allocation, I can tell you.
Ma'am,
Yeah.
ma'am, can you explain the pointer statement?
Yeah, okay.
Array one.
Yeah, this one actually what you have to do is, this is dynamic memory allocation. So first give declare an array size array I have declared. Then I am going to get the input from the size array now. So now first for the size array you have to give the, you are not going to get it through the initially like in your array statement, you are not going to get the elements. So you are going to create a dynamic space for it based upon the input of the user. If the user gives 5, only 5 memory allocation will be done. And if the user is giving 4, only 4 space will be allocated for the particular element to be inserted one by one. So each time when you give depends upon the user size. The maybe if you write a program in your array program, normally what you will do is you will give the size of the array as 10 or 100 or 50 or whatever it is. So based upon, you will be allocating. If you are giving the array elements of 100 even, it is not necessary that you have to give 100 elements in the array. You will be giving 50 or whatever it is. So that is the drawback in your array. Initialization is done. Once you have declared the array size, your memory will be allocated for that 100 size capacity. But in dynamic memory allocation, this won't happen. Your but that statement is only this. If you give this statement only, you can create a memory space dynamically. So that is use a pointer variable array1. Then this is your that is data type, your type def. I can tell you the data type of what you have. Integer array means integer, float na float, likewise it comes. Then malloc is the keyword which is used for dynamically creating the memory. And then again size of, which gets the size of the particular integer. That's what we are giving, the size of int. So this from here to here is your entire syntax. Actually, it is the syntax itself is like this only. Based on the type, you will be keeping on changing it over here. This integer, since I have given integer, I have taken out here integer star. Then malloc same as memory allocation, malloc only. Then size of the particular data type only, so int. Then again this array size is over here. So this is what you will be taking out over here. Now how to declare? Now this array 1, see P11 is same as array 1 only. This I will be changing it and giving it. This is array 1, or you can keep this as P11. Both are same. Now the particular size is being declared. Now what you are giving, that is when you give an input size of 1, maybe it will ask enter the number of elements you want to create, like n number, n items. The same thing only, this will also get the input n. So when you give 3, only up till 3 memory space will be allocated, dynamically allocated at the runtime only, not at the compile time. At the runtime, what input which you are providing only will be created for this array. This array 1 will create a space for the elements to be getting inserted only based upon the size which you are giving out here, 3 or 2 or 1, whatever it is. Now how to get the elements using the pointer variable? You have to now get the number of elements. You have got it, but now you have to give the inputs of the elements. Maybe if you have got 3 inputs you have you have to now give what all numbers to be inserted one by one. So to scan the elements, now you can use either ampersand, the particular array name of the index, maybe a variable, I variable, or else you can give P11 plus I. Okay, so this is the procedure. So it is not going to end with this program. Anyway, when I'm teaching you linked list, at that time, once again, I'll tell you more clearly, which gets you more clarification with the entire program in it. So don't worry.
Okay.
Yeah. So now this is your, next day only, next day we will be seeing about the linked list. Now we have to see an array matrix, which is an application of an array sparse matrix. I do not know how many of you are aware of this sparse matrix. So normally a matrix is a 2-dimensional data. So you know that it is m into n values. So when both m and n are equal, you know it becomes a square matrix. But what is called a sparse matrix? A square matrix is different. What is meant by sparse? Sparse matrix is nothing but normally it's an array with m cross, it is an matrix m cross n. But what is the elements contained in it is you will have more number of zeros in it. You will have very less number of non-zero values, more number of zero values than the non-zero values. Such kind of matrix will be called as your sparse matrix. So what happens is, if there are more number of zero values and only very fewer non-zero values, then what is the necessity for creating memory? Most of the elements are with zero, means that memory is normally getting wasted. There is a lot of space getting wasted to represent the particular matrix. So to avoid this lot of memory space to get avoided with this, we are going into a technique called two types of representation are there. One is your triplet representation, another one is your linked representation. So see, for example, you're having a matrix of 100 cross 100, okay, and all the values are zero except only 10 are non-zero elements. So in 100 cross 100, 100 into 100 means 10,000 elements will be there, right? There will be 10,000 elements will be there. So if there are 10,000 elements, in that only 10 are non-zero values. So these 10,000 elements, if it is of integer type, how much space it is occupying, you see? Only 10 spaces are filled with non-zero and remaining with zero. So totally how many space is allocated? 100 into 100 into 2. If your in size is 2, then 2. So 20,000 bytes of space will be wasted for storing this 100 cross 100 matrix itself. So what they are doing is, to access the non-zero elements, we have to also what it will be our procedure if you want to take the 10 elements out of this 100 10,000 elements. We have to scan it for 10,000 times, then only we can find the 10 elements. So scanning is also that is, finding the non-zero element is difficult, as well as lots of memory space also getting wasted. So what is the solution behind this? That only we are going to see it now. So example for a 3 cross 3 matrix will be, see here, 3 cross 3, there are 9 elements, but see here, there are only 2 are your non-zero elements, 1 and 4. Remaining all are 0, which is not at all needed by us. Need to be done for 100 cross 100 times. So instead of going in like that, this is only called a sparse matrix. So your example is given over here. Here that you can see here 3 cross 3. How many zeros are there? 1, 2, 3, 4, 5, 6, 7 zeros are there, but only 2 non-zero elements. So if I need to access 1 and 4, I need to go I, comma j, then again next one. Each row has to be scanned individually, which takes a multiple more time, and memory also getting waste. To avoid both of these, this sparse matrix can be represented by two ways. One is your triplet representation, and another one is your linked representation. So first we will see what is triplet, and then we will enter into our linked list concept. So triplet representation is like our array representation only, but the thing is, only the non-zero values will be considered along with the row and column index values. Remaining, we are not all going to look into the zero values at all. So normally how we are going to process you are going to make the array is, you will be having a three columns and how many number of rows based upon normally what you design. The 3 columns will be containing, like, one will be containing the index of the row, one will be containing the index of the column, and one will be the value itself. So you can see here one example I'll show you. See here, take down this example, triplet representation. So see here, there are 1, 2, 3, 4, 5, 6, 6 rows, 1, 2, 3, 6, 6 rows, 6 cross 6 actually, 6 rows and 6 columns. Okay, so how we are going to proceed is, now see here, from each row, and here see the first row in this array, the first row will represent the total number of rows, 1, 2, 3, 5 rows, right? 5 rows, and 1, 2, 3, 4, 5, 6 columns, and how many non-zero values, that is 1, 2, 3, 4, 5, 6. There are 6 non-zero values here. So the first row will be containing the number of rows, number of columns, and how many number of non-zero values. Now below that we are going to represent each row, from each row what is the value and its row index and the column index. So if my value is from the first row, when you take, you can find in the first row, that is from 0th row. Okay, 0th row, 1 0 1 2 3 4, fourth column, my number value 9 is there. Similarly, first row and not first row, 0 1, right? Yeah, first row and first column, so my value 8 is there. Similarly, when I come to the 0 1 to second row, I can tell you second row, but this is 0th column, so index is starting with 0. 0th column, the value 4 is there. Same row you have another one also, so second row, third column, my value 2 is there. Similarly, when I take here this row, third row and the last column, fifth column, my value 5 is there. And so this is the way of representing your this is called as triplet representation, row, column, values. So instead of giving like this the entire thing, so that zeros, I can use this rows and columns and print out the values over here. So this is one of the way of your same sparse matrix using array representation. But the other word I can tell you, it is called as, see here, it is triplet is one type of array representation only, but the name indicates triplet because we are taking only three things into consideration: rows, columns, and values. So when I want to make this as a code, see here, this is only a part of the code. So some M array, N array, I have got the values. So how it is getting printed is, for I is equal to 0 to M. That is from here this guy, then 0 to, so how this particular value, how I am getting is, if my particular array, that is if my particular value in the array is not equal to 0, then I can first take the, that is in one of the particular row, what I can take, this is I and j, so row and column, in one particular column, that is like this one value, this is only array of I comma j, and this is my ith value, this is my jth value. Okay, that's what represented over here. One particular, the value of the particular non-zero value, then where the particular non-zero value is present in the ith row and the jth column. So this is one way of taking out the values, and after that this will be used for your further process. Okay, so this is your array implementation only. Now if I go for the linked list representation, it is little bit different. In the first unit itself, I told linked list will be containing, linked list is also a data structure. This is the main data structure where we are considering the particular from here only your main concept of DS starts, because till now we have used only array, and why we are entering into linked list. So what is the necessity of entering into linked list? Now this I will tell you regarding your sparse matrix itself, but can you understand, students?
Yes, ma'am.
Yeah, okay.
Yes, ma'am.
So this I will represent by means of your sparse matrix itself. Anyway, in detail, we are going to see followed up PPT is in detail of your linked list representation. So here, normally I'll tell you what is a linked list. Linked list has normally has in a field, it has only two fields. One will contain the value and another one will be containing a pointer for the next, which stores the address of the next element. This is only your normal linked list. So here in when you are going to represent by means of sparse matrix, I need four node. Each node has four fields. Only one node. Each node will be having four field. The four field will be row, column, value, and the next node. Row will be containing, as I told you, the row element of the row value or the row index. Column will hold the column index of your particular element, and the value is which value you are having, which value is the non-zero value, and the next node is the address of the next element which is being stored. So what will happen when your pointer is in the first node itself? It will help you to after processing the first node, your pointer will have the next node's address. So what it will do is it will redirect your link to the next node to go where to go for the next node. That is what actually your linked list is. So when I want to represent, see here, this is an array. 1 minute. This is an array, and see the node structure will be in sparse matrix alone. I'm telling you, in your normal linked list you will be having only a value and a pointer to the next field. In sparse matrix there is an option of representing like a row value, a column, this is row index, column index, and the particular value and the address of the next node. So when I take this node structure, see here, it is started with 0. Yeah, started 0, 1, 2, 3, 4. Okay, 1, 2, 3, 4. So 4 rows and 5 columns. So starting with the 0th row, 0th row, 0, 1, 2. Second column, my value 3 is there. Okay, my value 3 is present. This is third field only will be having the value. Second field will be having the column index. First field will be having the that is row index. So now what is my next is non-zero value is in 4. So what I will do is I will represent in the same row only, but column is alone differing. And so what for next field where this 4 is present, see third field is only having the non-zero value itself. So what is your next field's address? That is where this particular node is stored. This address only will be in this fourth field. Okay, so now this address, now it will go here. Now again I can see in the first row, second column you have number 5. So 5 is present in the first row, second column. Then again 7 is also present. So first row, third column. So 7. Now again this row does not have anything. So I am not going to waste any memory for this. I will go directly to the 0, 1, 2, third row. Third row I will go to the first column. I have 2. And third row, second column I have 6. So I am not inputting any of the detail from my second row, because it is all zeros. So now this field will hold the address of the value 4. This field will hold the address of the value 5. This field will hold the address of, this field will hold 7's address, and this field will hold the second value 2's address, and this field will hold the value of 6 address. Finally, there are no more values. So my last address always it's null. Null means empty, no address. It is ended. Null will indicate the end of the particular node. Okay, this is your linked list representation. This linked list can also be represented in a different way. I'll show you a next representation. You can follow any one method. Then I'll go back to the declaration part. See here, this is also the same thing. Address of the next, that is your row list. This is array representation. You are showing pictorially, you are showing using linked list. That's all. So row list, row is from here they have started with 1, 2, 3, 4, but it is always good if you start from 0, 0, 1, 2, 3. So as per this slide, it is 1, 2, 3, 4. Now in this first row, what is being in this third column? Third column, my value 3 is there. So this is only the structure. Address of the node will be here. Column index is over here, column index, because row is already listed out, and value is 3 is only the value. Next, my value 4 is here, but where it is present in the first row, 5th column. My address will be here. Now this will hold the address of this node, fourth node. For this area, this will hold the address of the 5th node, and this will hold the address of the number 7. And 3, there is nothing there, so it is represented as null, and 4. But it is always best, this method actually will come in your 5th unit. There is a method in hashing called a separate chaining method. So at that time, this method only you will be using in the 5th unit. Hashing techniques, separate chaining method is there. There you will use this. But normally we are going to use only this method, linked list representation. This is the method which we are going to use in practice. And now when you see here, always my structure, this is the main thing. Wherever you are creating a node, you will be declaring. But for sparse matrix alone, you will be giving us row position and column position. But for our normal linked list, you will be giving in the node, in the structure node, you are creating a node. There, when you create a node itself, there will be defaultly two values only, that is value and the next address, pointer address, pointer. But in the sparse matrix alone, you will be having row position and the column position. So this is your